So what we're doing here is 4 semi-detached units. This is about 1,800 square feet above grade, plus there's about a 600-foot basement that's finished. There's a guest room and another bathroom downstairs. And we're building all 4 units to Energy Star 2012 specification, which is the latest Energy Star specification. Well, we're using Roxol, a lot of Roxol. There's Roxol in the party wall. There's R14. This is the party wall, so this is one unit. Through the party wall is another unit. So there'll be Roxol in there for sound attenuation and fire protection. And then there's Roxol in the exterior walls. It's an R22 bat. And then outside the sheathing there's R6 Roxol as well. The continuous insulation outside is significant because it really lifts your effective rating of the wall. When you put a bat in between the studs, you still have a wall that's 20% wood, right? And so that the studs will have less thermal resistance than the bat beside it. So you have to discount your. But when you put insulation outside, an R6 thermal resistance continuous will still provide R6 on an effective basis too. So that's why we did it here. It really improves the envelope. So, in terms of other things we're doing here to hit Energy Star, the windows are Energy Star windows. You can easily hit Energy Star with Energy Star windows. These happen to be better than that. They're fiberglass. They're like a high-end window. They're double glazing. Mm-hmm. There'd be a premium if we could put triples in those same frames. But there'd be a 20% premium on price. And okay. As a spec builder, it's like you have to decide what you can do. You can't do, you know.
Would you use a triple on the north side if there was a north side that's specific?
I would love to put triples in for somebody if they showed some interest. Yeah. They'd literally be the same frames.
Yeah.
Just a different, like in a double glazing, you use a stop that's this wide, and if you go with a triple, you just put a narrower stop. Yeah. So these could be retrofitted to glade. Yeah. So the roof, they're on-vented flat roofs. It's polyisocyanate. It doesn't sound that benign, but it's actually a fairly benign insulating. It's R6 per inch, which is a very high insulative value, and that's so. If we go up to the roof, you can see. There's the roof deck. This is the joist. There's a roof deck, and all the insulation is on top of that deck. There's no attic. So what it means is that insulation is continuous. So whatever your nominal R value is your effective rating too. Hot water tank. We went with a tank because tankless are fine, but they're very expensive, and there's a bit of a lifestyle change to them. You have to wait a little bit longer for the water to come.
Okay.
They're, I've heard them described as eco-bling. People like them because they're, wow, we can get a tankless, and I have one myself. They're fine, they're great, but they're quite expensive.
Yeah.
I think more cost effectively, we've got a hot water tank with an energy factor of 70, or 0.70. Right, and then we're linking it with a drain water heat recovery on the stack. So this is your sanitary stack. So in the basement, it's not in there now because people tend to steal copper in houses that aren't locked up.
They do.
So at some point we'll just cut a piece of the stack about this high, put it in this big copper tube. And so when you're showering, or when you're showering mainly, it's the best to exchange. When your warm water is running down pipe, the cool water is running up around, and it takes, 50%. You get some very high efficiencies. So effectively, you don't turn your shower as warm because you don't need to, because the cold water is a little warmer. So it effectively extends the capacity of your hot water tank. It extends the shortens the recovery time. If you have a piece of stack, like a long enough stack in your house, you can retrofit one of those in very easily. It's a good retrofit for you know, $600–700. You can do it, and it's conventional forced air,
Natural gas.
natural gas. So conventional from that respect, but it's 96% efficient. High efficiency furnaces are getting very high up there. And then the motor, the fan motor to actually circulate the air is an ECM motor, which is very efficient electrically. So you save as much on electricity as you do on gas. You know. Even the little inducer motors that once you hit high efficiency, the exhaust won't exhaust itself because it's so cold, it won't go out.
Right.
So you have to have a little fan that pushes it out. And that's why you can run it through plastic as well, because there's no heat in it. You've taken all the heat out of it. There's a heat recovery. We're building these very tight, so they'll all be blower door tested. And we're trying to hit a rating of about 2 or 2.5 air changes per hour. They say if your house is 1940, you have a hole about this big, and then as your house gets younger, 1960, 1980, the hole shrinks. But you still, even with that, you still have 3 or 4 air changes easily. 3 or 4, 5 or 6.
Yeah.
So I live in a 1920 house. I had about over 10 air changes per hour. And that's when you talk about a drafty old house. Yeah. That's when you do windows, you do air sealing, and now I've got it down to about 7, which is probably the equivalent of a 1980s house.
Yeah.
These houses will all have an HRV. There's a picture in there. It's very efficient as well in terms of the amount of heat exchange that occurs. And it's got 2, again, ECM motors. So one for exhaust air, one for intake air. So 2 little very efficient motors. And these things run continuously. You turn them on and you just let them run. And you don't, for the most part, you don't know. You go with a radiant or hydronic. It's nice, it feels great. It's incredibly expensive to do on a spec house. When you do it, ideally you get the best response when you just have a concrete floor. That aesthetic would go well with these houses, but a lot of people find that very austere. So, and then you start putting anything on top of that, cork or anything, it'll reduce the responsivity of the hydronic.
Yeah.
In these houses, we're going to do hardwood flooring, maple, for aesthetics and warmth. And so when you bury your hydronics, it'll still work, but you won't get the responsivity. The other issue with it is cooling. In Ottawa, we have pretty balanced heating and cooling. With a forced air system, it's much easier to tap in cooling into that same duct system. Otherwise, you have to have like a mini split, a ductless mounted high. They have these consoles. So you have your hydronic boiler at $8,000 or $10,000 just for the boiler, and then you'd have another system that's $5,000, $8,000 just for your cooling. So it does make a house more expensive, but it's a nice feature.
Well, and you can.
I'm very supportive of passive design, but unless you're on an acreage and you control the trees and the development beside you,
there's going to be some tall buildings.
In a dynamic transitional neighborhood, you got to be very careful, because if you design your house to have 40–50% of the heating load to be passive, and suddenly if someone builds a house beside you, then the economies are really in building passive and downsizing your mechanical. And if you start doing both, it's an expensive house, and you're going to have an oversized mechanical. And so what we did here, we've got moderate heat gain windows. So the U value is, 0.27, but it's a moderate heat gain. So it actually has a lower U value than it would have if it's a low E window. But what it does is temper that, because we're going to have some heat gain there.
Yes.
And so you don't want that to be a massive cooling load, so it
Right.
tempers that. The other thing we'll do is we'll also have a deciduous tree, like a, but inevitably it'll have to be some sort of a hybrid columnar species that you know, addresses some of that gain.
Mm-hmm.
Would you consider using like a screening of some sort, like a horizontally built out?
Well, we've got
slats
awnings.
to-
Ironically, we have awnings
Yeah.
on the back. They're
Oh.
just beginning to be built. There'll be
Yeah.
an awning over the door, but we don't have awnings there because it's this wasn't a design feature, so we didn't put them there. Part of the modern design is cleanliness, right? Cleanliness of, but you know, you can address it, and you can dress things like that in numerous ways. We chose to go with a modern heat gain and deciduous tree. Any heat that comes through your windows is in your house, right? So if it hits a blind, it'll maybe resist heating a bit, but it'll generally be in your house, right? Once it hits the blind, it converts to short wave, and then it's heat. So in Europe, they use roll shutters, so they're outside. People tend not to like them here; they look too fortressy, but they're, you know, in riot situations, you can lock down too. It's very, you know,
Especially
design process. There's all kinds of compromises, and so what we've done here is do a really good envelope and a good HVAC system. The windows are very nice. They're much better than conventional.